Turn number one is Happy on Wednesday. If you have your own laptop, then you show up in CIRS 1250. And make sure to bring power. So I think there's power next to each of the seats in that room, so you should be all set for power with your laptop. If you don't have your own laptop and you want to be using a lab computer, then you show up downstairs in the basement of the CS building in one of the labs. Just come to 008 and then they'll figure things out as to where you need to go. So the rooms are reserved from 6 p.m. So if you want a good seat in the house, then come early. Right? We're going to be there starting around 6, so just come early and you'll get the best seat. If you don't need the full hour and a half to do the midterm and think you just need an hour, come late. You know, that's also okay. What are we going to cover? We're going to cover everything. Everything that you learned. We haven't really covered any new topics that are not going to appear on the midterm. So everything, you know, that the lectures covered, everything that the lecture labs covered, everything that the assignments covered, and the exercises, so on and so forth. Everything. So today we have an hour, a little bit less than an hour. You can ask me anything. So this is your chance. So I'm here to answer all your questions. You can reference any code you want, any practice question that you saw you want me to answer. Concepts. Whatever. Okay. Okay, exercise step 2, number 5. Number 5. Okay, here's the question. The following method mutates the object used to invoke it, or simply access information about the object. So what we have here is we have change username. It's some method in some class. It takes a user object, it takes a string object, and then the user.set name, new name. So does the following method mutate the object used to invoke it? So what does it mean for an object that is used to invoke the method? No, it's not the parameter. So if I have some class, so I have class that, and then I have some method inside of it. Right? And the method is public void change user. Your name, and I have some arguments, and then I have some implementation, right? So this is a class S that contains this method. So for me to call this method, I need an object, instance of S, right? So I need to have something like S, new S equals new S, right? So now this object refers to a new instance of S. And for me to call this method, I now have to say new S dot change username. Right? So this is how we invoke methods. So the question is really asking about this object. Right? So the question is getting at, does this method mutate the object that is used to invoke it? Does this method mutate new S? Right? So if you look at the code, how do you refer to new S? How do you refer to the object that is used to invoke the method? Let me bring this thing up again. So I have this class S. In order for me to mutate S, that means changing something about it, right? It's changing its fields. So I might have a string here, like string name. So in order for me to change name inside of this method, how would it appear? How would I know that it's changing name? Yeah, so it'd be this dot name equals something else, right? I would be changing a field, right? But in the code, it says user.setName new name, right? So it's changing a parameter, so it's not changing the object that was used to invoke.
So it's not.
So it's?
So it's not repeatable because.
Yeah, it's not operating on that. More questions?
Sir, for this question, the object refers to the instance of the class where this method is.
That's right. So the object used to invoke it refers to the object that is. That's right. What else? What else do you get? Yeah.
On that question, if it said modifies this, could you assume then that actually the object is actually being modified?
Yeah, you mean the specification, right?
Yeah.
Yeah. If the specification said modifies this, then you would know that. Because that's what modifies does, right? That's what it's supposed to do. Yeah.
Random question. When you're doing a call graph, do you include the constructor methods, which will be included in this method or not?
In the call graph, do you include the constructor? Yes, you do include the constructor. Do you want to see an example, or?
Well, there was one example in the first code set in the call graph, I think, but there were no constructors there.
So there was a call graph, but there weren't constructors. Do you remember the question number?
It was towards the end.
This is here.
4.
That's a sequence there. That's not a call graph.
No, it was somewhere over there.
Yeah. So, but in general, when you have a call graph, remember that a call graph is simply representation of class.method strings, and you have arrows between them if you could call them. So you could have something like string dot string as a box. So this is a constructor for the string class. Right? And so you might say, well, maybe I call this guy from my change username method. So a constructor is just another method. It's a special method, but it's treated as any other method. Right? So I would call this guy, maybe I would call some other ones. And since string is in the Java library, right, we're not going to continue this on because we don't expect you to look inside of it.
We need the parameters for this or no?
Do you need the parameters for this in the call graph? No, typically you don't have parameters.
So we don't even need the brackets?
Yeah, you can even omit the parentheses. Yeah.
Can you go over question 7 in sample midterm 1?
In what?
Sample midterm 1?
And exercise 1?
No, sample midterm.
Simple midterm. Sorry, I can't hear you. Simple midterm 1, number what?
7.
7. Call graph. All right, perfect. This goes right into the call graph. Draw a call graph starting from the generate credit card payments autotrail.autotrail function defined in the main class. Stop method calls for any methods defined class outside of this. Okay. So let's see simple midterm. We have code spelled in the payment system. audit. And define the main class. Oh, sorry. Where's the main class? Generate credit card payments. Okay, so this is the one, right? Okay, so we start at the top. It's a call graph, so it's going to look just like this guy. So initially, I need a node where I start, and my node where I start is going to be main dot generate credit card payment. And then I have to find all the method calls that I invoke, right? So, no method calls here, no method calls here, no method calls here. Here's one method call, right? Here's another method call. Here's another method call. So I'm just looking for the method calls. It doesn't matter which order I add them to my call graph. They just have to appear there at the next level. So I'll just go in order of the lines, right? So this is the first one. So this is the coordinate card constructor. So I'll say coordinate card. So call number one. Then I can do one of two things. I can go breadth first, I can go depth first, right? So I can either go and find out what is being called from within this method, or I can go breadth first and find out other methods that are being called at the top level. So I'll just do the top level. So here's another one. This is a nested call, right? I'm calling math.random, and then I'm using the output of that and passing that to process payment. So math.random is going to be another method that I call. So add that on. Then yet another one that I'm going to add is process payment. So process payment is an S card. S card is a subordinate card. So I do subordinate card dot process payment. Dot. And then I have an audit payment record, so that's audit trail. It doesn't matter where I add these, right? Add payment record. And then down below, I have the else. Well, it doesn't matter that it's in an else. Yeah. Yeah, it is a Java class, but it should appear in the map in the solution. What does the solution look like? This is 7, right? It's probably not here. Yeah, that's strange. It should be in the answer.
So even if it's a Java class, we still
Well, you say that you don't follow them through, right? So math.random terminates, so it's a terminal node. So here, stop following method calls for any methods defined class outside of payment model. So you stop there, but you still have to mention. So that's a problem with the answer. Okay, and then I have ace of card. I have the constructor for ace of card. So I just do ace of card. Ace of card. I have math.random, but math.random already appears, right? So I do nothing. I create a double that hasn't been around before. So I know it's going to be a terminal node. I'll just put it at the top. Double dot double. Right. And then I have amount to string. So amount is a double. So again, it's going to be a terminal node. So I'll do double to string. And then process payment. A card is ace of card. I don't have that, so I'll add that in. It's looking really gnarly. And add payment record to an audit trail. And I think that's already there, add payment record. So this is the first level. And now I have to figure out which ones I'm going to pursue further down. So double is, this is done. Right, this is terminal, this is Java library. This is also Java library. This is also Java library. So I have 1, 2, 3, 4, 5. And I have to figure out where they are. Because the instructions say stop following method calls for any method defined in a class outside of payment model. So ace of card process payment. Ace of card is inside of payment model. So process payment I have to handle. I have to figure out which process payment I'm calling. Going to be a string. So process payment, what is it doing? It's just creating a new double. That's all. So process payment. Creating a new double. That's already a node, right? So I'm draw it like that. So that's done. And then subordinate card constructor. It's still in the payments model. Payment model. No method calls in subordinate card constructor. So this guy is done as well. Audit trail. Audit trail add payment record. So the payments process add is this is the function call here, the method. So payments processed is defined at the top. It's a list. So it's a list.add notification. So I add this guy, and then that's in the Java library. So both of these are done. I have an ace of card constructor. Ace of card constructor does nothing. There's no method calls, so this is done. And subordinate card.process payment. And in this guy, I have a few things that I'm calling. Right, I create 2 payment records, and they get transaction number. So those are really the only two calls here. Sorry, there's also 3. There's generate transaction number. All right, so there's going to be 3 things that are emanating from this guy. And I'm going to do a new piece of paper. Man, this midterm is hard. Good luck with that. Okay, so what do we have here? So prime process payment is going to generate three things. So I will. You can still see that, sort of. So three nodes. Right? And the three nodes are generate transaction number. So generate transaction number is defined within, well, generate transaction number is defined within electronic payment. So electronic payment. Generate transaction number. And if you look inside, F3 gets you inside, right? There are no method calls within generate transaction number, so we terminate at this guy. And then the second call is going to be get transaction number. So that's also electronic payment. Dot get transaction number. And if I look inside, there's nothing there. So no method calls inside of this guy either. Go back to here, there's going to be payment record. So I'm going to create a new payment record. That's a constructor. And so that's payment record dot payment record. Inside. All it creates a new string, and then also calls generate payment number. Generate payment number. So it calls a string constructor. So string, that's string. And we know we're done here. So we really have only one branch left, which is this generate payment number. And that's again, that's in payment record. Dot generate payment number. And does it go anywhere? It doesn't. We're done. Whew. Okay. Well, that took a while. That's what it looks like. Any questions about the process I'm following? So the instructions will tell you where you have to terminate, right? So like, don't go into the Java library, don't go outside of payments.model or whatever. And then I'm just looking for invocations of methods, right? That's the key thing. Yeah.
The string is included for payment record.
It's not included. Yeah, that's strange. I think maybe this course was taught differently before. Yeah, I don't see any Java things. So for you guys, you should include string.string, list.add, and math.random if they appear, right? So we assume that you can recognize that these are in the Java library, but you shouldn't go beyond this. Yeah?
Is that also card not process payment because like more methods?
If there's what?
Add more.
Also, process payment calls more things. He said process payment. He said, oh, you mean this guy? Let's take a look. He said card. Oh yeah, that's right. So so this was the very top one, right? Process payment from generate credit card payments. here's process payment. So yeah, it's a little tricky because so if I look in process payment, right, it's going to be essentially the same one, right? So it's going to be generate transaction number, and then it's going to be get transaction number, and then it's going to do the payment record stuff. Right, so really what this diagram should be doing is, there should be 3 things coming out, and all of these 3 things should be pointing to these 3 nodes. Because the subcard process payment and the Avis card process payment are very similar. Right. So I would make it kind of ugly, but essentially you just have these arrows that go in this direction and they point to these 3 nodes. Okay. Other questions? Yeah.
Actually, guys, one is secret class. So you need to check the ACID card class, right? And do they have overloading?
They have overloading, yeah, but I chose the one that was the double amount.
But it says string.
There are two versions, right? So here process payment, this guy, for the ACID card.
No, the ACID card is below.
Oh, that's the subordinate card. Okay, thank you. Great, this is super confusing. Good, thank you for pointing that out. So yeah, so there's 2 kinds of process payments, right? And the subordinate card, I guess we covered. Okay, good, thank you. So that's a mistake. So this guy process payment for an ACID card calls process payment with a string, right? So I'm going to follow this guy, and it's going to be just creating a new double and then calling process payment with a double within payment record. Yeah, so it's not going to look like this. Borrow this guy. Right, it's going to have 2 more things. So it's going to create a new double. And that's terminal. And then it's going to call process payment, which is defined where? ACID card.process payment. This is the double version of that. And then that does these 3 things, right? So then you have this node, and then it does those 3 things, so it's going to point this way to those 3. Okay? So it's a 1 level of indirection because you essentially overloaded process payment to take a string and a double, right? And then the string version will just create a double out of the string and then call the double version. So add 1 more layer to the hierarchy. The brutal question. Alright. Hopefully I got it right. Yeah.
If we ask to draw a call graph, are we supposed to note that? Are you supposed to jot down all the methods?
Are you supposed to what?
Are you supposed to write down all the methods, branch all the methods? Because I noticed that the answer key, not all methods have been written out.
The answer to what? Sorry.
The answer key, not all methods have been written out. Some of them are written out.
Yeah, so there's, you mean like the legend here? For the class names?
No, I think he's saying the Java methods are not included in the answer.
Yeah, Java methods are not included in this answer key. We expect you to write those in. Right. But you're always going to terminate at those. So basically you're just adding a few math.random, string.string, and double done. I mean, so there's no right answer as to what goes into a call graph and what doesn't. right? In general, there's like the rule of thumb for Java libraries is that you say, oh, I entered a library, and then I stop, and then magic happens, right? So that's what we want you to do. It says, I entered math.random, and then I don't know what happens after that. So, but we want you to indicate that. So in here, you can't really see that. You know, so it's less complete.
Do you want us to try and organize it like that one, or
That would be nice.
or does it really matter?
Yeah, yeah, this is really messy. You do your best. I mean, you're working under time pressure, right? So, like for example, one thing you could do is definitely use a legend for class names, right? So like M instead of main and so forth. So as long as you tell us that M stands for main, it's fine, right? So use whatever shortened notation that you want, as long as we know what it is. Yeah.
So, for a question like this, are the Eclipse tools that you could use fair game for an exam, or is there any way that you could say like explicitly don't use the tools or anything like that, or?
No, you should use everything. Yes. And Eclipse will tell you, right, what you're calling and stuff. So there was a way of doing this with Eclipse. Probably would have been easier.
Could you go through question 5 in the sample?
In the midterm, right?
Yeah, given a UML sequence diagram, how can we sketch the code?
Oh, great. Okay. So consider the UML sequence diagram. Let me bring this up. And below, sketch the code implementing the method create dataset on a weather data object. So WD is probably weather data. Create dataset is this method call that is described by this diagram. You may need to assume that there are likely return values from calls to methods. Handle these return values in the code you sketch. You can add comments to explain your code. You will not be grading for correct Java syntax. Great. So this is referring to, what is it referring to? Oh, here we go. Weather data, time series, MTD is monthly temperature data, MSC is time series collection. Okay, so I mean each of these is going to be a method call, right, in your code. So if you're writing the body of this method, then you're calling something within time series, then it's returning, you're calling get mean temp within MTD, which is monthly temperature data, that's returning, and so forth. So I think the key thing here is going to be figuring out what are the right return values to use and parameters to use in each of those methods. There wasn't any code associated with this, right? This is all that was given? Right. So I have class for the data. And then say public void create data set. Great. So I'm going to fill in the body. So here I need, so each of these objects, I need a reference to these objects. They need to come from somewhere, right? So the easiest way that I can get these is by creating fields. So I can say, well, there's going to be a time series TS. Let's define it at the top. Just assume that I have it. So then I'll do TS dot, oh, well, even better. I get to construct it, right? So I can say something like TS equals new time series. That's my first call. I just handle this first arrow and the first return of the arrow. Right? That's my constructor. Okay, and then I call get mean temp on MDP1 of a monthly temperature data. So where am I going to get these other ones? Well, I can do the same thing, right? I can define monthly temperature data field. Data, and I'm going to need two of those. So I'll do MDP1 and MDP2. And so get mean temp is called on MTP1. So maybe I'll have, I don't know, int mean temp 1 equals MTP1. Get mean temp. So this guy is handling the second call. I'm calling get mean temp on an instance of monthly temperature data, and the instance is called MTP1. And now I need to add mean temp 1 to TS. Well, I even got the name right, mean temp 1. Perfect. So now I do TS dot add mean temp 1. Okay, that handles the third case. Okay, now I have to repeat this for MDP2. So I'll have an int mean temp 2 equals MDP2 that get mean temp. And then I'll have a TS that add mean temp 2. Great. Now I have a time series collection. That's going to be my data set object. So the first step is going to call this method. This method is a constructor. So this is how I'm going to create it. So I'll say time series collection. I'm calling it data set. Equals new. Great. Now that I have a data set, I can call data set dot add series. Yes. I think that's it. I'm done. Okay. Yeah.
For the time series, TS, do you have to declare that before the method, or could you do it inside like you did with the time series collection?
It's unclear, right? From the diagram you can't tell. So you get to do whatever you want.
But both answers would be...
Both answers would be admissible. Yeah, you could declare it here inside the method. You could declare it as a field, right? Can't be a parameter because we see that it's not a parameter. So it has to be one of those other two. Yeah.
For mean temp, can we assume that it's a string also?
For mean temp, can I assume there's a string? Yeah, I guess. I mean, there's no types here, right? So mean temp has to be something. Yeah, it could be anything you want. Yeah, it just shows int. Random.
Different question that I've seen for class diagrams. I've seen examples where you use lists and arrows indicating possessives and things like that.
Right, you won't need to know those. Yeah. So I mean, exactly. We're only dealing with extends and implements. So I mean, the UML that you guys are learning is a subset of the broader set of UML that's available. It's much broader, right? There's all kinds of arrows. There's all kinds of boxes. But you guys are responsible for just two kinds of errors, the dashed and non-dashed. The implements and extents. Okay. Another question? Want to ask me something else? Yeah.
Exercise number 2, question 8.
Exercise number 2, question 8.
Yeah.
Why are formal reasoning techniques not applicable for most data abstractions? Wow, that's a very interesting question. Is it referring to something in particular? Yeah, well, so this question is kind of in the context of specifications, right? So remember substitutability, the way we think about substitutability, and the way there are those two rules, right, that you have to satisfy. And the first rule is that there's a constraint on the precondition, and there's a constraint on the effects, on the postcondition of the method. So in order to reason through those, so here what is meant by formal reasoning techniques, it basically says mathematics, right? Like, why is mathematics not applicable for most data abstractions? For reasoning through most data abstractions. And the reason for that is because sometimes mathematics is not powerful enough to model the thing you're creating, right? So if your precondition says, this credit card can only, authorized payment can only take a payment that's greater than 100. That's great. You can use a mathematical abstraction to model it. You can say it's a set with all the integers greater than 100, right? But if your method is something else, like, make sure that, the precondition is the person, the person just read an interesting blog post. What kind of precondition is that? I don't know how to express it formally. There's no way for me to model it. But that could be a totally reasonable precondition in, like Google Reader or Feedly or something, right? So it says, oh, you just read something very engaging, and the way I computed engagement is by seeing how long you spent on the page, right? Whether you followed links, whether you emailed it to other people, tweeted about it. So I could measure engagement, but it's very difficult for me to formally reason through that data abstraction, through preconditions and postconditions and so forth. So that's an example of why it's. Yeah.
Exercise 3, number 6. It's related to the
Okay, 3, number 6. Where's number 6? Solutions. 6. Given the classes figures and small figure as defined below, assume the method draw figure in small figure. So this guy does not have a call to super method. Okay. So 6A is B. So the first question is, when you run the following code, the draw figure method of which class is being executed? Okay, so this is great. This is all about dynamic dispatch, right? This is talking about apparent types and actual types, but in practice now. So I'm going to define figure A figure. I'm going to set it to be small figure. And then I'm going to say if A figure dot draw figure. So what is the apparent type of A figure? Figure. And what is the actual type of A figure? Small figure, right? Because that's the object that I created, small figure. So when I call draw figure, I'm going to call this method. Great. And there's no super in it, so that's all I'm going to invoke. So that's the answer. You guys got that? So this is, I really need to reason through apparent and actual types. I can't begin to answer this question without understanding that. Okay? So I have to know exactly what object I have, and exactly what type of variable I'm dealing with, the parent and the actual type.
Is there
your method in figure?
Yeah, there is. There's one here. And it's not abstract, right? So I can actually invoke it. Yeah.
If there was a super in that one, would you say that the method in small figure was executed, but then also the method in figure was executed?
Yeah, I would say it that way. I'd say that initially you end up in small figure to draw figure, and then that calls super, so you end up in the draw figure of figure.
Okay.
Okay, then B, when you run the following code, the draw figure method of which class is being executed. So now, my A small figure, the parent type is small figure, actual type is small figure. So draw figure is going to call it the exact same method. I'm going to end up in the same place. Because the implementation I select depends on my actual type. My actual type is small figure, so I'm going to end up in this block.
So the class would be small figure. Is that the answer for A and B? Because it's asking the draw figure method of each class. So that would be small figure class.
Yes.
If you have an interface and some other class implements it, would you say that the class that is implementing the interface is a subclass as well?
It's a subtype.
It's not a class.
Yeah, remember the classes really refer to implementation. So when you have an interface, so I might have some interface. Interface car. That it's implemented by something like Ford Fiesta. Right. So this is a subtype. This is a supertype. And there's no superclass. Right, there's just a class. But if I had extended this Ford Fiesta to be Ford Fiesta with an exclamation point. Right? Then this also would be a subtype of Ford Fiesta. It would also be a subtype of car. And then Ford Fiesta would be a superclass. But remember, when you're talking about subtypes and superclasses and supertypes, you need a reference point. Right? So I might point at this and I'd say, oh, this is a superclass of this, and it's a subtype of this. And then I might point at this guy and I might say, oh, it's a subtype of this, and it's a subtype of that, and it's a subclass of this. Done. Great. So Wednesday we're going to review the programming assignment.